Hello, my name is Gonzalez, and this time I'm going to talk about sorting algorithms. Really quick, I'm going to work with the bubble algorithm and the QuickSort, and I'm going to explain a little bit how it works. So basically, first of all, I need an array, and I'm going to say int array, oops, of elements. And I need a define of elements. I'm going to say 10 for now. So what I'm going to do is to populate this. So for int I equal to 0, I lower than elements, I plus plus. And what I'm going to use is array I equals to rand mode elements. So if I have 10 or 100, it populates with that number of elements. So I think I'm gonna create a print array function that sends the array and what I'm gonna do is to for int I equals to 0, I lower than elements, I plus plus, print f that's it. Then I'm gonna add a new line here. Yeah. Okay, so this should give me my array of elements. Let's take a look. sort c. Oops. For rand. Oh, I'm using an rand, but I'm not using parentheses. And then print array is not declared, of course. Void print array. And int array. Alright, so we have an array of 10 elements. Now I'm gonna call my function bubble, and I'm gonna pass my array. I'm gonna void bubble int array. I'm gonna do it over here, void bubble. Int array. So the way that the bubble algorithm works is that it's going to parse all the elements and swap the values based on the index and the next element on the index. At the end, it's going to do the final review to swap something, but if it doesn't find anything to swap because it's already ordered, the array is already ordered or sort, then it's gonna pretty much end its work. So to start with, I think I'm gonna need swapped boolean or identification, a variable that is going to be my first or the condition that is going to stop this is if it's equal to 0 or false. Let's do this. While swapped, I'm gonna say set it to true while swapped. Then I'm gonna make sure I'm gonna parse the array with an integer index. So for I equals to 0, yeah, I lower than LMs, I plus plus. So this loop is gonna continue analyzing from the position 0 till the position LMs until the swap has been completed. So I need to verify if the current the element of I in the array it's lower or it's greater than the element of the array I plus 1, and also I need to verify if I is not equal to LMs, because if it is, then we are at the end of the array. So if this is true, then I can do the swap array I by array of I plus 1. Because I'm doing the I plus 1, if I don't do this condition, then I'm gonna pretty much break this algorithm. So as soon as I do the swap, that will be it, maybe. So in order to know how many swaps we're gonna do, let's just add another variable that is called swap. Let's make it global, because we might use it for a different sorting algorithm, QuickSort in this case. Now that I have this, I have the swap. I don't have the swap function here, so I'm going to do it. Void swap int left, int right, but I'm gonna, this is in memory, so I'm gonna pass the address of this element so I can get the value later from this and swap the value to the right address. So int temp TMP equals to the content of the left side, then the left side is equal to the right, then the right is equal to TMP, and that's gonna be my swap function, and I need to do it here. Swap left int right. So now I haven't done anything with the swapped termination. So if there is a swap, I'm gonna say swap it's equal to true. But when I enter, I need to say that swap is equal to false. In that sense, I'm going to state that there is no swap, and if there is by any chance any swap, then I'm going to set it to true. And that will be maybe it. So I'm printing my array before, and I'm printing my array after. And also I'm going to print of swaps and swap. What's it called? And swap? Yeah. And swap plus plus, swap is equal to true. Let's take a look. Oh, how cool is that? Oh, there is something wrong because we don't have a 0 up here, but I have a 0 here, and I have a 9 here, and I don't have a 9 here. So it says that it did 34 swaps. So if something is wrong, let's take a look. Let's print the array over here. Okay, so this is the original, and this one of the swaps happens here, and then because this is the first swap, then 7.3 again it goes here, and then 7.5, then it goes here, and then 7.6 moves here, and then 7.2 of course is moving here, and then 9 stays there. So it's going well till here. It seems that it's moving this one here, and yeah, there is an overflow maybe over here. Okay, let's take a look. So let's say lower no. Let's lower that actually. But that's another mistake that I have there, but it's not the original mistake I'm looking for. I mean the one that I'm looking there. So swapped is equal to false. It's the swapped it's working as expected, and I'm doing the move. I'm moving in the right way because some operations are going well. So this is okay, it's okay, it's okay. If it is 10 elements, I'm passing. I'm having one error there. There it is. So yeah, 3675, 91. Perfect. So this is the bubble algorithm simplified. If you see over here, the 77 is moving till here, and then it stays there, and then we continue the parsing, and then it moves the 1 and 9, and then apparently it goes back. So yeah, the next iteration is going to be through the 5 and 6, which is because this is moving here, and now the 6 and 3 have to be swapped because the 3 is lower than the 6, etc. So yeah, it works. Now if we number of swaps was 24. Let's do this and let's try it with more elements. Let's say 100 elements. This should work. Yeah, these are a lot of elements, but on a quick look, 2, 3, 5, 5, 8, 11, 12, etc. 93, 94, 95, 96. So yeah, it works. So we have lots of operations worked as that. So this is a very expensive operation or sorting algorithm. So what I'm going to do now is to implement one that is one of my I wouldn't say favorites now. There are too many sorting algorithms lately that I've discovered, and some of them are not even in my radar or were not even in my radar before. But the one that I like to use is the QuickSort. QuickSort, and I'm going to send the array. And QuickSort, it's an algorithm that is going to ask for a pivot. The pivot is going to be usually the last number on the right of the array. So we're going to set the two let's say pivots, the one at the lower position and the higher position. And the one in the higher position is going to be the value that is going to be moved till we make it the new pivot for a new partition. So we're going to split the array in different partitions and finding new pivots, and the final pivot is going to allow us to see the real sorting of this, and the number of iterations and swaps is going to be way lower. So I have my array already. I have my array there. And what I need to do first is to pass my array, the low and the high, so my low is going to be 0 and my high is going to be LMs minus 1. Yes, minus 1. So the first operation that I need to do is to find my pivot. And actually the highest value is going to be the one in the position high. So I'm going to need to use, of course, if it's going into partitions, the partitions are going to be splitting the elements. So the first thing is my pivot. No, my partition is going to be based on my array and my high, my low and high elements. And yeah, and since I'm going to be moving from the left to the right, I'm going to need to recall QuickSort, but with the array, of course. And the low part is going to be, if I'm going to go to the left, it's going to be the low, and the pivot -1 because it's going to come. Yeah, my pivot, my position in the pivot is going to be the one that stays, but I need to check the partition on the left, so it's going to be like that. So my QS array, then I'm going to go to the right, so it's pivot +1 till the highest in the position. Yeah, I think so. Yeah, so what I'm going to do is to void swap QS array Now I'm going to use a partition. The partition needs to return an integer, which is the index or the new pivot position. Int partition int array int low int high. Yeah. So void partition int array int low int high. So I'm gonna get a new pivot, but first I need to know the value of the pivot, which is in the highest position, because that's gonna help me to compare everything. So let's call it pivot, but it's not an index. It's not a pivot based on the index. It's a pivot based on the value. So that's my the value of the pivot, and I'm gonna need to parse from left to right. So I'm gonna move an index, which is gonna be I, from the very bottom, or the one on the low or left, which is the value. It's the index, yeah, the left index, and I'm gonna have to parse in another variable So I is gonna move till find a new pivot. So I is gonna help me to return I, which is gonna be the pivot, the new pivot that is gonna be partitioned later by this recursive function. And from here, I need to see if the value that the j, which is the one that I'm moving right now, is lower, the value in the array of the position on j is lower than the pivot value. Oh. Then I can do the swap. Yeah, but let's do this pivot value. I can do the swap, and I already have the swap function. So, but what I'm gonna swap is the array, the element on the I position with the element on the j position, not the I and y and j are gonna switch to the values in the most simplistic way. If there is only two elements and this condition is true, then they're gonna be switched. But if not, if this is a long array while we move I, they're gonna be switching. So we're gonna move the value and the. But the point is that when we get to the pivot, the new pivot is gonna stay in one position, and then it's gonna be split again. Yes. So I'm gonna swap. I with array j, and that's it. Well, I guess I'm gonna use my counter for swap to see how it goes. And that will be it. I think so. Let's see. A partition QS. Let's see. Oops. Have many conflicting types for partition in the line number 37. Let me do something here first, because there may be some other errors. QSO. Wait, 25 and 14. Okay. Seems like 25. QS array. Okay, so first this is integer because I'm returning I. There's a problem with QS. It says int array. Oh. Too few arguments. Oh, I'm sorry. Line 25. Oh, of course. So. I'm sorry, I did the Now we we have partition array. Passing over of partition makes integer from pointer without a cast. 32. Oh. Passing argument one of partition. Oh. It's a partition. 32. Oh, yeah, this is swap makes a pointer from integer without. Oh, okay. So the swap here, I'm not sending the address. Of course, it will not work. Not it. Let's see. All right. Okay, I have it in 100. I'm gonna move it to 10. Anyway, I'm expecting a segmentation fault. Seems like I'm doing something wrong over here. I is low. Oh, okay. I think I'm doing the swap, but I'm not moving I. Let's see. Okay. It's a segmentation fault. I think this has to go to equal, and then I'm swapping I and J. Let's see. Okay. Pi plus 1. So basically, let's see. Here. Maybe. So I was thinking that J will go from 0, but we don't know where the 0 is. The 0 is not 0, it's low. So yeah, let's try. Okay. But this is right, should be low. Okay. Okay, they both start at the bottom, which is good. J is equal to high. Okay. So it's a segmentation fault means that I don't know. So let's try here. Just to see how many times it gets there. Oops, so many times. Actually, let's try this. Seems like this condition only happens once. Okay. So recursivity is working pretty well, but there's a segmentation full cost. So this is, let's see what's in here. Oh. Okay, so this condition is not happening. And then this continues. I'm not sure what's going on. Bit of partition. If it's not getting here because J. So I think we need to verify here if low. Here. If low is lower than high, because if not, yeah, let's try. Number of swaps 0, so it got into got here. It's good news. It didn't get here. If I write J is lower than the value, then let's swap it. This swap was not counted. The swap didn't happen. The array was printed once, was not printed twice. Was it? No. Oh yeah. Okay. That's because of the excess. So it was printed twice, but swaps didn't get into here. Well, we don't have the segmentation full for now, which is good. Yeah. I'm not sure why this is not working. It's supposed to be like this. Okay, let's see the values of print f. Okay. Okay. 3, 1. So it's always 1. This pivot, it's always 1. I mean, this pivot value, it's always 1. Okay, after doing some pause and coming back, I found that what I'm missing thing is that we're getting always the last element, right? And we never have a true condition here, because this pivot value is always going to be 1. So what I found is that we can switch or swap the new pivot with the high element. And then it becomes the pivot, and I was missing that. I think so. So I'm swapping. I need to send the address. And voila. 1, 2, 3, 3, 5, 5, 6, 6, 7. So 3, 3 is 2 times, 5, 5 is 2 times, 6, 6. 6, 5, 5, 6, and 3 and 3. So it's good. Now, if you remember, we had like 2,400 swaps with the bubble. With 100 elements. So if we change this to 100, you will see that we only had 262 iterations here. So it's way faster. QuickSort is way faster than the bubble. So I have the 2, 3, 5, 8, 11, 12, etc. 62, 63, 67, 93, 94, 95, 96, 99. So, yeah, that's thing. So if you look at the time, it took me a while to find out why this was not behaving as expected. And yeah, I went back to the algorithm to check it and to understand what I was missing. And I was missing the position of the new pivot. That's it. Thank you so much, and thank you for your patience in the last minutes.